Suppose there are two independent economic factors, M1 and M2. The risk-free rate is 7%, and all stocks have independent firm-specific components with a standard deviation of 51%. Portfolios A and B are both well diversified. Now, we have the betas on M1 and M2 and expected returns of 30%. What we need to have is expected return is equal to some intercept plus beta of M1 times expected M1 plus beta of M2 times expected M2. Well, we know the betas. And let me see. Actually, expected return minus risk-free. All right. So what we don't know is expected returns on M1 and M2. So we basically need to solve these equations. Let's do this in Excel. Let's see. Stock A, stock B. Expected returns are 30 and 11. 1.6, 2.3, 2.4, negative 0.7. All right. I have a risk-free rate. So the risk premiums are let's remember what the risk-free rate is, 7%. Now I also need expected returns on M1 and M2. I'm going to put arbitrary numbers, 2.5, 0.2. So model risk premiums are some product of the expected returns on the factors and the betas. Obviously, these are going to be fixed. All right. And what I'm going to do is I'm going to, let's do this. Difference between risk premium of the stock minus what comes from the model. And I'm going to calculate sum of the squares of these. Now, if I have the right M1 and M2, these sum of squares need to be 0. So I'm gonna go to Data tab, use Solver. This is my objective, and I'm going to make that equal to 0 by changing what we don't know. No constraints. Unconstrained variables do not have to be negative, and hit solve. It did find the solution, and these are the unknown numbers.